Today is the last day of notes for chapter 5. We will start chapter 6 when you get back from spring break. So that was well timed, I must say. The next 2 days, on Tuesday and Wednesday, will be review days. The review was posted on Friday. It's posted on the class website. The pictures are there, not the answers. But I will not be here tomorrow. It's the regional elementary school track meet. That's tomorrow.
What's your daughter's name?
Adeline.
Is she gonna take a dub?
How far did that come?
Yeah.
Wait, is it a triathlon?
She's gonna run relay.
What did she run? What did she say? High jump and what? What do you mean?
Long jump, high jump, and relay. That's what you're talking
Oh,
about.
so she got running.
And then, so she's really a runner. Somebody messed up.
Oh, dude.
Yeah, it's bad. So, at any rate, I'll be there. Okay, we are looking again at the multiple angle formulas. We talked about these on Friday. So, sine of 2u. Sine of, this is called double the angle. Sine of double some angle expands into what? Oh, 2 sine, yes, you're right. 2 sine u, cosine u. All right, twice sine u, cosine u. All right, and so again, we have this double angle. Today, we kind of learn exactly what that looks like because a lot of students have trouble understanding, well, can't I just find the sine of the angle and then double it? Not how that works. So that's what a lot of students want to do, but that is not what this is doing. So I'll talk about that today. We also have cosine of a double angle. We had 3 different choices. I really liked the first one the best. That was cosine squared of u minus sine squared u. That's my favorite personally. But then we can also do some trig substitution, some Pythagorean identity stuff. What's another equation we could get?
1 minus
2 sine squared u, and then the other one could be 1
minus 2 cosine.
plus 2 cosine squared u. I don't have these memorized, so. Did
Sorry,
you?
I'm using the
Okay,
first
somebody
one.
take a second and look in your notes from last Friday.
Yeah, 2 sine squared. Minus 1.
Oh, 2 sine squared minus 1?
No, for the cosine.
For cosine. 2 cosine squared u minus 1.
Yeah.
Yeah? Okay, there we go. Okay. So, all these were from Friday, and so we have a choice. All right, so here we go. Example 1. Find the exact values of sine of 2u and cosine of 2u using the double angle formulas. And in your book, it does ask you to do the tangent of 2u, but I'm not requiring you to do that because if you know sine of 2u and cosine of 2u, how do you get tangent of 2u? Sine of 2u divided by cosine of 2u will give you the tangent of that. So it's just unnecessary to do that. Okay. Using the double angle formula. So they're very specific here, and they're telling me that tangent of some angle u is -1/2. This is a trig equation, and anytime we have a trig equation, what do we do? Draw the triangle, draw the picture, okay? And this is u as in regular angle u, and we are trying to find sine of twice that angle and cosine of twice that angle, and that's our goal. But the first thing we want to do is, of course, draw the picture. Now, Remember tomorrow that since I'm not going to be here and you're going to be working on your review, there's quite a few problems and many of them are odd, and I did that intentionally. Remember that all of the odd problems in your book have worked out solutions that you can get online at www.calcchat.com. Pick your book, type in the chapter and the section, and you'll get all the worked out solutions. So that will be very useful for you. Now, when you do that, sometimes the book is gonna not do it how I do it because they do it the very algebra way. You want me to write that down? So they do it the very mathematical way, which I don't do. I do the kindergarten version of trigonometry, which is let's draw a picture. Okay. Which is good. I like it. All right. Tell me what this stuff is doing here. What does that mean?
That's the range, isn't it?
I heard range. Range of what?
Range of the graph or the period.
No,
Sure.
not period.
Make it up.
Stepped out. Anybody else? What is 3 pi over 2? How many degrees? Oh. 270 degrees and 2 pi is 360 degrees. And so this is telling us that our angle is between 270 or quadrant 4. Oh, so it's telling us which quadrant. Really, really important that we know which quadrant our angle is terminating in. So we have here terminating in quadrant 4. Here we have our angle U. And whenever we draw that angle U, then what do? Drop an altitude. So we create our reference angle or reference triangle. That then we can label. What sides do we get to label for our U prime?
Opposite adjacent.
Opposite and adjacent. So the opposite gets -1 and the adjacent gets 2. And then what do? Find the third side. Sure. So 2 squared plus -1 squared equals our radius squared down here. Radical 5. Very good. All right. So now we have our triangle labeled. And so a lot of students think that, oh, well, sine of 2u is going to just be the sine ratio, which would be -1 over radical 5, and then double it. And sure, that's the sign of double our angle. And that's not what's happening. The order is important here. Sine of twice the angle means, well, I only know information about angle U. And I know that angle U is somewhere between 270 and 360 degrees. So I'm going to pick a nice number. Maybe to estimate. I'm just going to guess what this looks like. I'm going to say maybe U is 300 degrees. Well, we want to double that. And if we double 300 degrees, then that's 360 all the way to like here. So this angle is 2u. And it would land somewhere in the third quadrant. So this is an angle that's twice as large. And now we want the sine of this thing. And I know nothing about this double angle except where it might land. Okay? Because of that, we use a formula. What is the formula for sine of double an angle? 2 sine u times cosine of u. So we expand it and we use a formula and it does all the work for us. What is the sine according to angle u that we already drew? Okay, negative radical 5 over 5 is true. I'm going to leave it -1 over radical 5 and you'll see why. And then what is cosine of angle u? Adjacent over hypotenuse, so 2 over radical 5. And we just get to multiply straight across. 2 times negative 1 times 2. You know what the favorite answer is? Negative 5. You see that, right? Yeah? Yeah. That's what everyone does. They look, and you see it is some reason. Negative 5 is the answer I get most often. But we are multiplying, so this becomes what? 2 times 2 is 4 times negative is negative 4. Radical 5 times radical 5 is 5. Yes, so the hardest part is actually the multiplying. So be careful. All right. Then we have our cosine of double the angle. Again, I know nothing about the double angle except it might land in quadrant 4, or it's not 4, 3, sorry. But I have formulas that help me out, formulas that use my angle u, which I do have information on. So my favorite formula for the cosine of the double angle is cosine squared of u minus sine squared of u. That is my favorite. And it's my favorite because when I do the cosine of u, God bless you, adjacent over hypotenuse 2 over radical 5, I get to square it, and what happens to the radical?
It goes away.
Yeah, it goes away. So it's just really nice. And then sine of angle u, opposite over hypotenuse, so that's negative 1 over radical 5, and don't forget to square that. So that becomes, what is 2 over radical 5 times 2 over radical 5? 4 over 5, good. Subtract, and negative 1 times negative 1, radical 5 times radical 5, and 4/5 minus 1/5, 3/5. And you know, you may need common denominators and stuff like that, but I like that one because we square it and the radicals disappear for us, which is kind of nice. Okay, so this is how these formulas get used when we're talking about the actual angles that we can draw versus solving equations where we just trade out equations. Now, one more thing here. Any questions on this one? Please make sure that you read the directions. I had so many questions first period, and they were trying to do the wrong thing. Like, they weren't reading the directions. So please read the directions, and here we go. Now, I need you, example 2, use the power reducing formulas. On page 407. So please open your books to page 407. Use the power reducing formulas. Now, in your book, there's this little symbol in your book which has this black box, and then there's this squiggle that passes through it. That squiggle is called an integral, and that's calculus. And so anytime that I see problems where the book says, hey, you're going to see this again in calculus, I try to do those so you kind of see that, oh, I remember briefly doing this in pre-cal last year. So we try to do those often.
So is calculus just like a harder version of what we're doing?
Math every year. Math is about learning a skill, practicing a skill, and then being successful at that skill. So calculus is the next step. You've learned everything, and then calculus, we take it one more step up. Okay. It's just the next level in math. All right, so we want to rewrite the expression in terms of the first power of cosine. And so we have on page 407 some formulas. And the formulas are, if you have sine squared of some angle, you represent some angle that we're talking about. And you can see right now this has a power of 2. Well, it turns out there's a really nice formula. 1 minus the cosine of twice what we started with. Twice what we started with divided by 2. And those two things turn out to be equal to one another, which is kind of nice. And so we would go from a second power to no power at all, which is a lot easier to work with. They also have a formula for cosine squared of some angle. Turns out to be 1 plus cosine of double what I started with over 2. So they're very similar formulas, small difference between them. And what I would like you to do is I want you to take a second while you're looking at your book and look at example 5. I'm going to give you 30 seconds to look at how they started on example 5 because you've got problems very similar to example 5. So look at each step and think, okay, what'd they do? What'd they do first? What'd they do second? I'll give you about 30 seconds. I just want you to see how they got started.